Welcome to Isinamuva Tutoring 2. This is Peter from Fosloras. In this video, I'll be introducing you to a very effective strategy of solving Euclidean geometry problem. Now, remember in the last video, I introduced you to Dr. Cape Town, which will help you recall the theorems. If you haven't watched that video, the link is in the description below. Whenever you approach a question, do not go looking for the theorems in the diagram. What you must do, you must apply this strategy called one thing leads to another. So the one thing leads to another strategy works this way. You'll have to go through the statement to collect some useful information, and then from there, you just focus on the given angles. Those given angles are your starting points. Let's say you are given an angle of 30 degrees as a starting point. So we'll say, what relationship does this 30 degrees have with the angle I'm looking for? If it's 2 marks, you'll just get the relationship straight away, and the relationship is by the theorem. If it's 3 marks, then you'll have to start somewhere else and then get to the angle you are looking for. But the strategy works either way. And then after getting the angle you were looking for, that angle then becomes your starting point, your new starting point. To say, what relationship does the angle that I just got have with the next angle I'm looking for? And so on and so forth. But before applying the strategy, you'll have to check these 5 things first and highlight them on your diagram. 1, you check for equal lines, check for parallel lines, check for 90 degrees, check for turn-chord angles, and check for an exterior angle of a cyclic quad. If you have any of those, you go highlight them in your diagram. Special Girls 2017 Prelim. Now, you first read through the statement to extract some useful information, and then you identify the starting points. The given angles are your starting points. So Q3 is the potential starting point, W1 is the potential starting point. Now, before using the strategy one thing leads to another, you check for equal lines to say, are there any equal lines on my diagram? And the answer is no in this case. Are there any parallel lines on the diagram? Yes, there are parallel lines. TS is parallel to QW, and that suggests that W1 equals S1, and then you highlight those equal angles. Any 90 degrees? No. Any turn-chord angles? Remember, turn-chord angle is an angle between a tangent and a chord. So Q3 is a turn-chord angle. You're going to highlight Q3 as your turn-chord angle. And by turn-chord theorem, Q3 equals S1, S2. So you're going to highlight S2 as well, the same way as Q3. Q1 is a turn-chord angle, and Q1 by turn-chord theorem equals W1. W1 is already highlighted, so we will have to highlight Q1 the same as W1. Are there any exterior angles of a cyclic quad? No. And then we go to the starting points to say, let's say the starting point is Q3. We go to Q3 and say, what's the relationship between Q3 and the angle we are looking for? Or if the starting point is W1, what's the relationship between W1 and the angle we are looking for? If it's for 2 marks, we're going to find the relationship straight away. If it's for 3 upwards, then we'll have to start somewhere else before we get to the relationship between those 2 angles, or before we get that angle we are looking for. Now, the first question wants us to calculate with reasons angle S1. So angle S1 is already highlighted red, just like W1. So angle S1 has to be equals to W1. Ours is to find the reason why these 2 are equal. So S1 is 70 degrees, yes. Reason is alternating angles. After writing alternating angles, you'll have to tell them that these two lines are parallel, QW and ST. Now, after getting S1, your S1 then becomes your new starting point. You're going to write it on the diagram, and then it becomes your new starting point to say, what's the relationship between S1, my new starting point, and the angle I'm looking for. So now they want us to calculate angle V. Angle V. So what's the relationship between S1 and angle V? So what's the relationship between angle S1 and angle V? I'm sure you can see now what the strategy does. It simplifies the diagram, because by asking the relationship between S1 and V, you are actually ignoring all these parts of the diagram, Your focus is on S1 and V, and it's easier that way. So S1 and V are opposite angles of a cyclic quad. Remember, STVW is a cyclic quad. So the relationship between S1 and V is that S1 and V are opposite angles of a cyclic quad, and opposite angles of a cyclic quad are supplementary. So S1 plus V equals 180, then V becomes 110. Reason, opposite angles of cyclic quad. Now, V becomes a new starting point to say, what's the relationship between V? Remember, V is 110. What's the relationship between V and the angle we are looking for? Now, we are looking for angle Q1. Angle Q1. What I'm noticing is that angle Q1 is already highlighted red. Now, Q1 is a tan chord angle, so the relationship has to be tan chord theorem. According to tan chord theorem, Q1 equals W1, so Q1 is 70 degrees. Reason, tan chord theorem. And then you write your 70 degrees on the diagram, and Q1 then becomes a new starting point to say, what's the relationship between Q1 and the angle we're looking for? So now we're looking for angle Q2. So what's the relationship between Q1 and Q2? You can't be looking at Q1, Q2 without looking at Q3 as well. So Q1, Q2, and Q3, if you remember when we were still introducing lines, these are angles on a straight line. So we have Q1 being 70 degrees, Q3 being 30 degrees, Q3 is then 80 degrees. So that angle Q1 plus angle Q2 plus angle Q3 gives us 108. Q2 is 80 degrees, angles on a straight line. Then we are done. This one is from Eastern Cape 2016 prelim. We read through the statement to extract some important information. Okay, we were told that O is the center, RBP is a tangent. We identify the starting points. B4 is a starting point because that's a given angle. B6 is a starting point as well because that's a given angle. Now, before applying one thing leads to another strategy, we'll have to check for equal lines. Are there any equal lines on the diagram? Yes, remember OD is a radius and OB is a radius, so these two are equal. And that makes triangle ODB an isosceles triangle. Are there any parallel lines? No parallel lines. A 90 degrees, yes, remember radius is perpendicular to tangent. So radius is perpendicular to tangent. This is a 90 degrees. Any tan chord angles, remember a tan chord angle is an angle between a tangent and a chord. B6 is a tan chord angle. I will take B6 only. So B6 equals, by tan chord theorem, equals the 3 and 4. That's your tan chord theorem. Any exterior angles of a cyclic quad? No exterior angles of a cyclic quad. Now, the first question wants us to calculate with reasons angle O1 for 3 marks. So if it's 3 marks or more, you'll have to start somewhere else before you get to the angle you are looking for. Now, we can't just go straight from B6 to O1. And by the way, B6 is already highlighted, as you can see. So the starting point has to be B4. With what I've just said, remember I said because it's 3 marks, we won't go straight from the starting point to O1, but we'll have to start somewhere else. So where does B4 takes us? B4 equals D3, angles opposite equal sides. So we have D3 equals 30 degrees, angles opposite equal sides, or radi. Now D3 then becomes the new starting point to say what's the relationship between D3 and the angle we are looking for. I'm not sure if you notice we're still on the same triangle ODB. Now we have two angles in this triangle. We're looking for the third one. So that's your sum of angles in a triangle. That's how we're going to get to O1. So O1 is 120. Sum of angles in a triangle. 30 plus 30 is 60. 180 minus 60 is 120. Now, O1 then becomes a new starting point to say what's the relationship between O1 and the next angle we are looking for. We are looking for angle A. So what's the relationship between O1 and A? So when you look at O1 and A, you can see that there's a relationship between O1 and A. Angle at the center is 2 times angle at the circumference. So A is going to be 120 divided by 2, which is 60 degrees. Angle at the center, is 2 times angle at circumference. And then A becomes your new starting point to say what's the relationship between A and the next angle I'm looking for. So we're looking for angle C. Angle C. What's the relationship between angle A and angle C? Angle A and angle C. These are opposite angles of a cyclic quad. Angle A and angle C. These are opposite angles of a cyclic quad. So angle C is then 120 degrees. Remember, opposite angles of a cyclic quad are supplementary. 180 minus 60 is 120. Opposite angles of cyclic quad. Then you have your 120 as a new starting point. Angle C is the new starting point to say what's the relationship between angle C and the angle we are looking for. Now we're looking for angle D, angle ADB. That is angle D in triangle ADB. So we're looking for angle D in triangle ADB. Where is triangle ADB? This is triangle ADB. So angle D in triangle ADB is angle D4 and D3. Angle D4 and D3 is already highlighted blue. So it's equals to angle B6. And that's by Tan-Code theorem. So angle D is 70 degrees. Reason is Tan-Code theorem. So that's how the strategy, one thing leads to another, goes. And it always works, regardless of the allocated marks, regardless of how complicated the diagram might look, regardless of how hard the question is. One thing leads to another strategy always works. So please be sure to understand the strategy and apply the strategy. Always remember to look for these things. Before attempting any question, you check if you have parallel lines, equal lines, 90 degrees, tan chord angles, and exterior angle of a cyclic quad, and then you go use your one thing leads to another strategy. This one's from Eastern Cape 2017 prelim. The first thing we do, we read through the statement to extract some useful information. Okay, on the statement we were told that BS and PQ are parallel as indicated. QR and SR are equal as indicated, and ABC is a tangent. Now we check if there's any of these. Are there any equal lines on the diagram? Yes. And they suggest that Q2 equals S3 because RQS is an isosceles triangle because of these two equal sides or lines. Are there any parallel lines? Yes. And they suggest that angle S1 equals angle P2, alternating angles. Is there a 90 degrees? No. Are there any tan chord angles? Yes, B1 is a tan chord angle, and by tan chord theorem, B1 equals S1, and I've already highlighted S1, so I'll have to highlight B1 the same way. And B3 is a tan chord angle, and by tan chord theorem, B3 equals P1. So this is how I'm going to highlight these two. And then I apply my strategy. One thing leads to another. That is to say, okay, these are starting points. Remember, you'll have to identify starting points. This is a starting point, the given angle B3. This is a starting point, the given angle S1. So now they want us to calculate with reasons the size of B1, angle B1, and it's already highlighted. B1 is already highlighted. It has a red star, the same as S1. So that means B1 equals S1, and that's true by tan chord theorem. B1 equals S1, so B1 is 30 degrees. Reason tan chord theorem. Now B1 then becomes my new starting point to say what's the relationship between B1 and the angle I'm looking for. Now they want me to calculate angle P2. P2 is already highlighted, the same as B1, but you can't go from B1 to P2 because from B1 we use tan chord theorem to get inside the circle. So P2 has to be equals S1 for that reason. Remember, these are alternating angles, P2 and S1. So P2 is then 30 degrees. Reason alternating angles, BS is parallel to PQ. Now, I'll have to write my P2 on the diagram, and then P2 is the new starting point to say what's the relationship between P2 and the angle I'm looking for. So now they want me to calculate angle R. Angle R. Remember, the starting point is P2. So when you look at angle P2 and angle R, you can see that these two are opposite angles of a cyclic quad. opposite angles of a cyclic quad are supplementary, remember. So R1 is 150 because 150 plus 30 gives us 108. So opposite angles of cyclic quad. Then you write 150 on the diagram, and that's your new starting point. Now they want us to calculate angle Q2. Angle Q2. Now, angle Q2 is on the same triangle as angle R. And that triangle is an isosceles triangle. Remember, whenever you have one angle on an isosceles triangle, you can always find the other two unknown angles. Now, Q2 equals S3 because these are angles opposite equal sides. Remember? Now, Q2 equals 180 minus 150 divided by 2. I'm sure you can recall this because we did this when I was still introducing you to triangle theorems in the previous video. So Q2 is 15 degrees. Therefore, and then you are done. This one's from Eastern Cape 2019 prelim. We first read through the statement to extract some useful information. So in the statement, we were told that BE is a diameter. So this is how I highlight a diameter so that I won't forget. So BE is a diameter. Now we check if there's any of these. Are there any equal lines? No. Any parallel lines? No. 90 degrees? Yes. Remember, an angle subtended by a diameter at the circumference is 90 degrees. So this is 90 degrees. Angle A is 90 degrees. And angle D2 is 90 degrees. These are angles subtended by a diameter at the circumference. Are there any tan chord angles? No. Any exterior angles of cyclic quad? Yes. E3 is an exterior angle of cyclic quad ACDE. So E3 equals C2. Again, E3 is an exterior angle of cyclic quad ABDE. And angle E3 equals angle B2 and 1. So these are equal. Also, D3 is an exterior angle of a cyclic quad ABDE. So D3 equals angle A by the theorem. So this is 90 degrees as well. And even by angles on a straight line, it's still 90 degrees. Now I've went through this. Now I'll have to go to the diagram and highlight or point out the starting points. I have two given angles, B1 and E3. Those are my starting points. To say what's the relationship between, say, E3 and the unknown angle, or what's the relationship between B1 and the angle I'm looking for. So the angle we are looking for is BAE. And that is angle A in triangle BAE. Where is triangle BAE? BAE. So this is triangle BAE, and angle A in triangle BAE is 90 degrees. we have already highlighted that angle A is 90 degrees. So 90 degrees, reason angle subtended by diameter. Remember, BE is a diameter. So angle A is now a new starting point to say what's the relationship between angle A and the angle and an angle we are looking for. We're looking for angle E1. Where is E1? I'm not sure if you notice that angle E1 is in the same triangle as angle A, and that is triangle ABE. In triangle ABE, we have B1 being a 50 degrees, angle A being a 90 degrees, and therefore angle E is 40 degrees. And sum of angles in a triangle. Sum of angles in a triangle. Triangle theorems are so important. That's why I started off by introducing you to triangle theorems, straight line theorems, parallel line theorems. The next question wants us to calculate. Remember, after getting angle E1, we'll have to write it on a diagram, and that's our new starting point. So the next question wants us to calculate angle C1. So what's the relationship? Remember, E1 is our new starting point. So what's the relationship between angle E1 and angle C1? So when your focus is on E1 and C1, you can easily see that these two are angles in the same segment. So angle C1 equals 40 degrees. Reason angles in same segment. Because your focus is not all over. You just here and here. So you can easily see the relationship between the two. Now, C1 is the new starting point. We write C1 on a diagram to say what's the relationship between C1 and the angle we are looking for. Okay. Now we're looking for angle C2. Angle C2. And angle C2 is already highlighted red the same way as E3. So these two has to be equal, angle E3 and angle C2. Ours is to find the reason. The reason is then the exterior angle of a cyclic quad, as we've discussed earlier. So C2 is 65 degrees, reason exterior angle of cyclic quad. Now, C2 is the new starting point to say what's the relationship between C2 and the angle we are looking for. So we're looking for angle A. We're looking for angle ABD. That is angle B in triangle ABD. Where is triangle ABD? Triangle ABD. So this is triangle ABD. Now we're looking for angle B in triangle ABD. That is angle B1 and B2. Angle B1 and B2 is highlighted the same as angle C2, the starting point. So angle B1 and B2 equals angle C2 equals 65 degrees. So what's the reason for these two being equal? B1 and B2 and C2. B1, B2 and C2, that's angles in the same segment. So angles in same segment. Okay, this one is from Eastern Cape 2015 prelim. You read through the statement to extract some important information, and then you go through these. Thereafter, you follow the strategy. One thing leads to another. in the statement we were told that O is the center of the circle. Now, are there any equal lines? Yes, OS equals OT. Because OS is a radius, OT is a radius as well. Are there any parallel lines? No. Any 90 degrees? No. Any tan-chord angles? No. Any exterior angle of a cyclic quad? No. Okay. Then we identify the starting point. Angle S2 is the given angle. That's our starting point. So we're going to start at S2 to say what's the relationship between S2 and the angle we are looking for. Now, they want us to calculate angle O1 for 3 marks. So if it's more than 2 marks, you don't get to an angle you are looking for right away. You'll have to start somewhere else. So to say, where does S2 leads us? So S2 leads us to angle T2. Since OST is an isosceles triangle. So from S2 we can go straight to angle T2. So angle T2 equals X. Reason OS equals OT, radii, or angles opposite equal sides. Then T2 becomes the new starting point. To say, how do I go from T2 to O1? From T2 to O1, remember, we are still in the same triangle, so you think of triangle theorems. O1 then equals 180 minus 2x. That is the sum of angles in a triangle. Then we have 180 minus 2x as the new starting point. They want us to calculate angle P, with O1 being the starting point. What is angle P? This is O1, this is P. Angle at the center is 2 times angle at the circumference. So 180 minus 2x over 2 is 90 minus x. Angle at center equals 2 times angle at circumference. And then we have a new starting point, that is angle P. What's the relationship between angle P and the angle we're looking for? We're looking for angle R. So from angle P to angle R, those are opposite angles of a cyclic quad. So angle R is going to be 180 minus 90 minus x, that is 90 plus x. Opposite angles of a cyclic quad. I'm sure you're now familiar with the strategy and how to apply the strategy. In the next video, I'll be going through some more challenging questions on the strategy, and then I'll introduce you to proving whether or not a figure is a cyclic quad, whether or not a line is a tangent, whether or not a line bisects angles, whether or not lines are parallel, and so on and so forth. Be sure to subscribe, like, comment, and turn on the notification bell so that whenever I post a video, you get notified.